Okay, today is called identities. It's chapter 13, and here's what an identity is. It's just a truth. It's a fact. Now, I could give you one, but you wouldn't necessarily have to believe me. Bob is 95. But that's not something we necessarily would all agree on because, like you don't know that to be a fact. Okay. Now, if I said that 1 plus 1 equals 2, that would probably, other than a few of you who just like to argue, would probably be something we could all agree on is just a fact. Okay, now we've also got certain facts that, you probably would agree with, like the Earth is round. Well, actually, a sphere. How about that? Do you get there are some people, really, who believe that the Earth is flat? So if you were arguing with someone, you could not start with the premise that, well, of course, the Earth is not flat, because they would like to start with the premise that the Earth is flat. So you have to agree on a set of facts before you can, start to argue, start to have a reasonable, proof of something, okay? So if you could say, for example, Bob had a better math ACT score than Jim, and Jim has a better ACT score than Aaron, then Bob's is better than Aaron's. Okay, you can use, that's called a transitive property. All right, so if you can agree on certain facts, you can prove things with that. So here's a fact that I'm hoping we all can agree on. That if I go over in the x direction this far, and in the y direction that far, and if the radius is 1, and then we call this angle theta, do you remember this is what gave us that sine was y? What is the sine of that angle? Well, it's y over 1, so sine is y. So that's one of the things we've kind of agreed on, that I showed you where it came from. Hopefully that was enough of a proof for you that you can believe that sine is the y. How about the x? What's the x? Cosine. So there's a fact. And then from that fact, we can get a ton of other facts. If we can agree that that situation is true, that the sine is the y, the cosine is the x, and the radius is 1, do you get that sine squared plus cosine squared must equal 1? That is the first one of the facts you need to write down on your sheet called identities. Sine squared plus cosine squared is equal to 1. Now, we also, I think, agree on some basic rules of math that if I wanted to, I can add anything I want to, as long as I do it to both sides. And I could subtract anything I want as long as I do it to both sides. So if this is a fact, then here's something I could derive from it. If I subtract cosine squared from both sides, then I would have, these two would cancel, right? I'd have sine squared theta is equal to 1 minus cosine squared. It came from the original fact. Now, you would not make a list of all the things that you could prove from sine squared plus cosine squared equals 1. You want to keep your list down because, believe me, even as it is, you're going to have to memorize like 9 things. That's one of them. But this came from that black one, sine squared plus cosine squared equals 1. This came from it, and so it's also true. It's just a derivative of the first one. Do you get I could have subtracted sine squared from both sides if I wanted to? All right. I could have subtracted 1 from both sides, and that still would have been true. Okay, so that was your first fact. Your second one also comes from that first one. And yeah, I could say just memorize the first one, but these are pretty common. You're going to use them on today's homework, for example. If I divide all of these, can I divide by anything I want as long as I do to everything? Isn't that a thing? Let me make sure you really believe that. 2 plus 4 is 6. Is that true, first of all? Then do you get I can divide everything by 2 if I want to, and it should still work? And that's 1 plus 2 is equal to 3. Still works. See, can you buy it that I can divide by anything I want, as long as I do it to both sides? Okay, so then I'm going to choose to divide by sign. I'm actually dividing by sign squared. One more little thing. The squared is not on the theta. Notice that the squared is on the sign. It's not on the theta. We're not squaring the angle. Okay. Why did I just do that? Because now I have a new fact. What's sine divided by sine? 1. Plus, what's cosine divided by sine? Usually there's somebody that knows that one. Cotangent, very good. And what is 1 over sine? That's hopefully one of the ones you've memorized too. It's the sister functions, you know. Which one's 1 over sine? The flip of sine. Cosecant, very good. That blue one, that's another fact you should memorize. And I got a snappy saying that I learned from a teacher who learned it from another teacher. Some of the best ideas are just copied. The one with the coat is cozy. Snappy little saying that helps you remember that one. This blue fact is going to come in handy when, for instance, they ask you to prove something and they have cosecant squared in the problem. You'll be like, well, I know that cosecant is this, so I can put that wherever I see the cosecant. You're swapping. Like if you see 50 cents in a problem, you can pull that out and put in 1/2 of a dollar? If you see 6 inches, you could pull that out and put in 1/2 of a foot? You're just pulling out one thing and putting in another that's equal. That's called a substitution. You can do that. So wherever you see cosecant squared from now on, you could put a 1 plus cotangent. You'll see later why you'd want to do that, but I'm going to just derive the last fact here, which is, what did I do to get this blue one? I divided everything by sine. What do you think I'm going to do next? Divide everything by cosine. Yep. And you do not have to show all of this. That would be a lot of work. I'm just going to ask you to see where I'm getting these. Just see what I'm doing. I'm taking a fact and I'm doing something that's legal to both sides. And now I have a new fact. What is sine over cosine? Tangent squared. Notice they're both squared so that I get a tangent squared. Plus, what's cosine over cosine? 1 is equal to 1 over cosine, which is what? Secant. Those three are called the Pythagoreans. Why? Because they all come back to a squared plus b squared equals c squared, which is the Pythagorean theorem. So those three are the basis of almost any time you ever see a sine squared in a problem, you should be thinking, ooh, sine squared plus cosine squared equals 1. Just you pull up that memory of like, ooh, I bet it has to do with this. There's certain things you kind of tie together in your head. Like when I hear Elon Musk, I know the next person's probably going to be talking about one of his companies that he has, like Tesla or like SpaceX or the Boring Company. He's got a lot of companies. Neuralink is another one. He's trying to figure out how to get humans to be able to interlink their brain to a computer. It's an interesting idea. Okay. So anyway, I want you to see secant squared and go, oh, I bet it's that one with the tan is what you seek. That's why there's spray tan solutions. Because the one with the tan is what you seek. All right. So those three facts, let me give you an example of where you might use them. Give me just a second to move this up. I'm going to take off these circles around each thing. Okay. Oh, and I got to get these off of there too. There. There's my 3 sets of facts. Here's an example question. Now, the fact that we just talked about this stuff means that maybe some of you are like, oh yeah, that's obvious. But if you just see this problem without the context of these facts, I'm going to move it up so that you can't see those facts anymore. You just look at that question and somebody says, prove that 1 over 1 plus cotangent squared is equal to sine squared. That's pretty abstract. Know what I mean? Like, it's really hard to like picture that or to understand why that would be true. So then you just got to go back to, well, what are some facts we know? I think some of you are going to be able to see the 1 plus cotangent really easy. Oh, that's just cosecant. So I can take out 1 plus cotangent and I can put a cosecant. So here's how I would show my work. A typical problem and on the test, typical test questions are proofs. You prove that that is a true statement. But we've all agreed that 1 plus cotangent is cosecant. I even showed you where it came from, so you can be confident it's true. So now I'm going to rewrite this thing and say 1 over cosecant. Because what did I do? I traded out this for this, and that's exactly how I'd like you to show your work. I pulled out 1 plus cotangent, I put in cosecant. And notice on the right-hand side, I am just going to leave it alone. It's going to be very tempting at times to like, oh, I'm just going to subtract 5 from both sides of my proof. You can't do that. Do you remember proving before in that other unit? Remember how you could only touch one side? You couldn't manipulate both sides. You couldn't like add 6 to both sides. Not legal when you're proving. You double check with the people at higher level math than me, and they all agree that it's best, there are weird exceptions, but it's best to prove things by only manipulating one of the 2 sides. Okay, so then, one more thing. I'm going to give you a few more things we'll agree on. I haven't listed this yet, but does anybody know what that is? 1 over cosecant? It's sine. So then if it's 1 over cosecant squared, it would be sine squared. And then this, of course, is itself. Don't have to prove that. Sine is sine, and that's how you end all your proofs, is with a fact. Just like last time. I don't know if you remember that, but last time when we had to prove stuff, you had to come up with exactly this equals exactly that. It has to be the same on both sides. And every step in between has to be a fact. 1 over cosecant is sine. So now, I gave you a starter list of facts right there. And if you want to label those were called the Pythagoreans. The next little set here is going to be called the reciprocals. And those are ones we've already talked about, and I just used one a second ago. 1 over cosecant, that's sine. But I'm going to give you a nice clean list of the reciprocals. I'll just move this over a little bit. All right. Sine of theta is 1 over cosecant. Now, if you really want an extensive list, you could rearrange that and say that cosecant is 1 over sine. But I don't think you need to make too many things to memorize. If you know this one's true, it's like the converse is also true. Let me give you an example. If I am taller, I better pick somebody I actually am taller than. I don't know if I've got Ethan beat or not. Dang, who am I for sure taller than? There's a lot of, I'm taller than Wagner. I think I am. then do you get how I don't really need to list that Wagner is not as tall as me? That's just like obvious. It comes from the first one. I said I was taller than Wagner, so I don't have to list that Wagner is shorter than me. So it's the same idea as sine is 1 over cosecant. You don't have to list then. You should just be able to know that cosecant would be 1 over sine. All right. So, yeah, I know. I was shorter than more than just you. There was other people I could have picked on, but I picked on you. Thought you could handle it. So let's go to cosine of theta is, what's that one? 1 over secant. And the last of the reciprocals, what do you think I'm going to write? Tangent, and that's equal to what? 1 over cotangent. All right, I'm going to erase this stuff. Make room for one more little set of facts. It'll be nice for you if you have one set of facts that you have to memorize. There's going to be some more complicated ones coming, but I don't expect you to memorize them. I feel like life is a little bit that way. Do you get that as a math student, you probably should know that 9 times 3 is 27? You shouldn't have to be able to look that one up. People will judge you if you can't do 9 times 3. Okay. But if it's 98 times 39, they wouldn't judge you at all for grabbing a calculator. Anybody would grab the calculator to do that. It would just be super impressive if the kid could do it in their head without the calculator, right? Same idea. There's certain ones of these that I expect you to just know, and you ought to know because you could see them on the ACT test. Yes, this stuff we're doing right now is one of the harder things that are on the ACT, these facts. And they don't give you a memorized sheet. They don't give you like, here's all your formulas, and these that you see on the board here. In fact, really you could get away with just memorizing this top one, couldn't you? Because then you could always divide by something and get the other ones. Okay. And then these three, you need to know them. They're not going to give you that on the ACT, so you ought to know those. There are really complicated ones you're going to learn like 2 days from now that I don't expect you to memorize. And you can just pull up off your sheet. We're going to give you a sheet. And some things aren't on the sheet, and some things are on the sheet. The complicated ones, they're on the sheet. Just like in the real world, the complicated math, you're probably going to grab a calculator to do it. Some stuff you should have in your head. All right, so here's the last ones I want you to have in your head. You ought to know these. I shouldn't have to have these on any sheet anywhere, okay? And these are called the quotients. Quotient. The quotients. What does quotient mean, by the way? Divide. Just like product means multiply, just like difference means subtract, and there's one more. Sum means add. Okay, good. So the quotients, it starts with this one. I bet somebody's going to know. If it's a classic trig thing having to do with divide, somebody's going to be able to guess this. Yes? You are correct. Tangent is sine over cosine. And just like I said, you could derive all the other ones from this. Like if you knew the sine plus cosine, sine squared plus cosine squared is equal to 1. If you knew that, you could get the other two. You can know tangent and then get something else from it. I know you know. See if somebody can fill this up. If tangent is sine over cosine, what's going to be an offshoot from that? Don't say sine over cosine is tangent. I know, that's the exact same thing except reversed. Yes? Okay, now what you just made is a proof. What you said is right, but it's not something that we would memorize as a quotient. What you made is a proof, and I'll show you. We're going to do proofs in a minute. What do you say? I don't think you mean cosine. Can you say that one more time? Okay. Interesting rearrangement of the first one, but it doesn't bring in any new information. I get what you're saying. You rearrange this one, and you did it right. Cosine would be sine over tangent, but we don't use that one because it's just rearranging the same one. Oh, it's killing me. I know you know. Anybody else want? You have to bring in a new function, otherwise what's the point? You got to have some new function that's related to these guys. What do you think? Yes, cotangent is cosine over sine. Why? Because we just basically did the inverse of both sides. And at least we got a new function in it. We now have a cotangent. Okay, so here's a typical, easy question. Prove. Prove that. Oh, wait a minute. Sorry. Squared. Cotangent squared plus tangent squared, sorry, times tangent squared, is equal to sine squared plus cosine squared. This isn't actually a super easy one, but it is a typical one. I can give you easier ones to do on your own, but I'm going to help you with this one. Write this down. Give yourself an example of how to do a proof. So again, if I'm trying to prove to somebody that the Earth is not flat, you can't start with things like the Earth is not flat, obviously. You have to start with something like you can agree on. Okay, so maybe you could agree with that person that things that are way off in the distance appear smaller than things that are close to you. They might agree with you on that one. You know what I mean? And you get them to agree that, yeah, things that are off in the distance are smaller than things that are up close to you. And then you could like try to explain how if the Earth was flat, wouldn't things that are on the horizon, like if you looked close enough, if you got like binoculars, shouldn't you be able to see things that are a long ways away? They'd just be really short. So like when you're out in the middle of the ocean, how come you can't see any land? Even with binoculars, even with super binoculars, even with like a telescope, you can't see any land off in the distance. And so maybe it's because the Earth is a sphere. Okay, but you got to start with something they can agree on. So tell me, what's something that we would all agree that I can replace this with this, because it's just a fact. Come on, you need our strong math students to step up here. Give me some thoughts. And I know you may not be perfect. What do you say, W? Hey, W? Okay, I agree. We can replace this, but don't. Here's why. Because if I manipulate the right side, I can only touch the right side from now on. And now I'm stuck with a 1 over there. It is true, but it's not going to be helpful to replace this with a 1 because now I'm going to have to somehow turn a 1 into all that. So I'm going to pick to not make that substitution, even though you're right. So that's an important thing to learn. Just because it's a fact doesn't mean it's going to help. All right, in the back corner, sir. Okay, hold on. You're saying I could replace this with cosine over sine, and you are correct. That's right off my sheet, right out of the quotient section. Now, does that give you any thoughts about what he might do next? Like, why is he going that way? Well, maybe it's just because it's true, but he doesn't really know. Notice I'm squaring both. It is that simple. If something is on the sheet and is not squared, if it's squared on the sheet, then I'm not going to say this right. Okay. if we know sine is 1 over cosecant, it'll still be true if I square both sides. Know what I mean? That's just a math thing. You can square both sides if you want. So 1 squared is still 1, right? So they work when they're not. If it works when they're not squared, it's going to work when they're squared. Okay. So anyway, you guys know that cotangent is really cosine over sine, but you might need proof, so to speak, that it's okay to have them be squared. It is. All right. Another way to say that would be, couldn't I just break this into 2 of them and cancel one of them? And then, anyway. So, there. Yay. I've done my first substitution, and I think some of you know where I'm going next. Yes? Okay. Keep going. All right. All right. Now, there's a long way to do this, which would be to switch around the bottom parts and then make it cosine over cosine and sine over sine. But do you get, in the end, these are all going to cancel, and it doesn't just cancel and disappear. They all, when you cancel stuff like this and this, they technically get replaced with what? 1. So that's all I'd expect to see. You can't just cross off everything. You'd have to cross them off and replace them with 1s. And then I would want you to show that 1 over 1 times 1 over 1 is what you have left. And then that, of course, does simplify to 1 equals, and then you might be like, but wait, I still don't have this. It's not like I don't have sine theta plus cosine theta. Can't I replace 1 with? Yeah. Most of you guys are used to sine squared plus cosine squared equals 1, but it's also true that 1 equals sine squared plus cosine squared. So I can replace this 1 with sine squared plus cosine squared, and I can now bring down this ending. Sine squared plus cosine squared. You know you've done your proof properly if the very last line is exactly the same on the left and the right. You only messed with one side, and every substitution you made came from our list of things we agreed upon. Like cotangent is cosine over sine. That was on the list. Tangent, that was sine over cosine. That was on the list. When you cancel things and you use math, just make sure you show your work. Yes, things can cancel, just like they always have been able to cancel. And technically, we could call it reducing. We reduced it to 1. And then 1 times 1 times 1, of course, is 1, because you can use simple math, like 1 plus 1 is 1, or 1 times 1 is 1. Wait a minute. 1 plus 1 is 2, but anyway. Okay, cool. That's how you prove something. I'm going to give you a very simple little proof and see if you can do this without, just make sure you show your work right, because most of you will be like, yeah, I know that's true. Pausing for a second. Okay. Did you find 1 over cosecant somewhere on that sheet? Hopefully you did. And it was sine. And then you got sine theta times sine theta. So the only swap we made was this. I like a little arrow like that to show me what you changed. Don't have to tell me what you didn't change. That we can assume. Then, these two together would make sine squared. That's just math. Thankfully, this is not like 2-column proof. Do you remember in geometry where you had to say, like, why you can do that? Okay, you don't have to write out because of the property of, multiplying or something like that. You don't have to prove it. I mean, you're proving it, but you don't have to list your reasons why this is true. It's just if you ever try to do something that's not a fact, then I'm not going to be able to accept it. Okay, and then the last part is, can I just replace these with 1? Yeah, because it's on the sheet. It says that those are 1. So I'm going to replace that with a 1 equals 1. Does it have a statement at the end that's identical on both sides? Yes. Did I only mess with one of the 2 sides? And did each step have proof that off the sheet that you can do that? There we go. All right. That's the beginning. They will get much more complicated. But I'm going to show you one more thing that's just kind of like a reminder of like how math still applies here. If that's true, then I can subtract sine on both sides. And this must be true. You can use math and take facts and rearrange them with math, and it'll still be allowed. So if you ever saw a cosine squared, just a cosine squared in a problem, you could replace it with 1 minus sine squared. Can you do that in your head fast enough? If cosine is 1 minus sine, what do you think sine would be? 1 minus cosine. Yes?
I feel like rearrange it like that, not switch to our work.
You do not have to show your work even off on the side. If you just insta replace this with that, I'd be totally okay with it because it comes from a fact that's on our sheet. It's a derivative of a fact that's on our sheet. Okay. So, let's get to the homework. Everybody try to find this page right, it's in 13.1. This page is just the Pythagoreans that we already, we already got those, so no need to, I'm just reminding you that they're in the notes if you want them. And this is strategies. I've talked to you about these already. You can only mess with one side, and don't simplify something down super far, because then you can't, like, isn't that one where somebody wanted to replace sine squared plus cosine squared with 1? Well, what am I going to do with just a 1? It's going to be really hard to go from there. So basically, you take the complicated side and you try to make it more simple until it equals the other side. I gave you a list of the reciprocals and the quotients because those are the ones that happen the most. You can get common denominators. That is going to come up. We won't have it much on today's, but common denominators is a really good, powerful thing. Simplify sums or differences of squares to one term. I'll show you that one in a second. Multiply by conjugates. Coming later. We don't have to worry about what a conjugate is yet. And if you find yourself stuck working with one side, try starting on the other side. Because remember, you can work on the left side or you can work on the right side. You just can't do both. So if you tried the left side and you can't make it work, switch to the right side. All right. So here's our first one. And there's only 4. So I'll just tell you right now, you can cross off the last one. I'll save you some time. But if you feel like you want the challenge, go for it. It's not impossible. It's not super hard. You can tell by the little 5-minute things here that the teacher thinks that's a not super hard one. But I'm trying to cut your assignment down to reasonable. So number 92, the first one. Do you see anything on there that seems like you could pull it out and replace it with something? 1 minus cosine. It's kind of a derivative of, I'm going to write it, you do not have to do this, but I'm going to show people why this is okay. Because that equals 1. And I can say that 1 minus cosine is just me subtracting cosine from both sides. And look at that. Sine squared is 1 minus cosine squared. So I can replace this with sine squared. Now I have sine theta over sine squared theta is equal to cosecant. Can I just say, well, that's obviously true? No, you have to keep going until it's identical on both sides. Now, would you agree that sine squared is actually a sine times a sine? You can just bring ditto marks down for the right side. You don't have to keep copying the same thing on the right side over and over and over. And do you get why I broke them up into 2? So I can cancel 1. And what do you replace things when you cancel them? You replace them with what? 1s. And now I'm left with 1 over sine. Ooh, and I know what that is. What's 1 over sine? Cosecant. Equals, and look at that. Now I bring it down. On the last one, you can't have ditto marks. This needs to be identical to that. There we go. Cosecant equals cosecant. I proved it. That's the first one. Remember, if you get stuck, there's a key. But I want to warn you. These are very, like, once you see the key, you'll be like, oh, yeah, that's easy. It's very easy to fool yourself into thinking you're totally fine. I totally get this. Because whenever I look at the key, I know what to do. Okay, if you don't know what to do before you look at the key, then that means you weren't really good at this. Once you look at the key, it'll be obvious. Okay, so you got to get good at doing these without looking at the key. So I'm not saying you should never look at the key. I'm just saying don't lull yourself into thinking, oh, these are easy. Happens to kids all the time. They looked at the key every time, understood when they saw the key doing it, but they can't do it themselves on the test. We're just going to follow up with today's relatively easy test with, this will be a tougher one. Stay with me and you'll be okay, but if you decide to slack off this week, this is not a good week to slack off. All right, that brings up the topic of the old test. I have them graded, but I also knew that today was going to be a little bit long, and it's a math day, so there's not enough time to actually give you your test back to inspect. I apologize. It happened in the last hour or two. I thought I could speed it up, but I'm looking at the clock, and I didn't. Sorry. But I would rather have you not go home confused, and you get your scores. I'm going to promise I'm going to put them in right after school. So at 3:15 today, you can look on Schoology and see your score. You'll actually get the test back tomorrow in class. If you really, really need to see it before then, come in today after school, which is a time you can see me, or tomorrow morning. You can see it earlier that way if you need to. Otherwise, you can physically see your test tomorrow in class. All right, that's all I got for you for today.